All right, we're going to skip section 6.4 and go to 6.5. 6.5 is something called sequencing rules and determining the configuration of a molecule. Okay, let's say I have these two different enantiomers, enantiomer A and enantiomer B. How do you name them? And how do you know which enantiomer you have? So let's have a bottle of this, and I say to you, this is a bottle of the D enantiomer. Well, you would have to go to the analyzer and analyze which way it goes. All right, but you don't have a sense of what the molecule looks like. All right, just because it shifts the light to the right, that doesn't tell anything about the structure of the molecule. So the sequencing rules is completely man-made, and it's how do you determine which molecule you have. So let's get our molecule that we've been using. All right, BrClOH, and let's have the enantiomer of that. I'm going to actually draw it like this, put Cl in front, Br in back, and OH. So these are two different molecules. How do I name them, first of all, and how do I represent that this is the molecule I'm talking about? Okay, you would have to know that this is the D or the L, or you would have to know that the other one is the D or the L. Okay, but if you don't know that, usually people don't, because not many people have this type of analyzer. There has to be a man-made way, a very quick way, that you can determine which molecule you're talking about. All right, and this is what's called the R and the S configurations or rules. Okay, it has nothing to do with the D and L. Okay, so there are two rules you got to determine. Okay, so just to kind of show you right now, the molecule on the left is the, hold on, I got to figure it out, is the R enantiomer, and the one on the left, or the one on the right, is the L. Sorry, the one on the left is the R enantiomer, the one on the left is the L enantiomer. Okay, well, how do I know that? I'm going to give you the rules. Okay, first of all, you have to assign priority to groups around the chiral carbon based on atomic number. So just like how we did the EZ rules. Okay, so assign priority, and it's 1 through 4, to groups around chiral carbon by atomic number. Okay, 1 is the highest priority and 4 is the lowest priority. Okay, so let's do it using the molecule. Okay, so first priority, bromine has the highest atomic number, so that gets priority 1. Next is our chlorine. Chlorine is next atomic number, then oxygen, and then finally hydrogen. And the rules are the same as E and Z. So if you have a tie, you go to the next 3 atoms, and whichever atom wins is the one that gets it. Now, so this is rule 1. Sorry, rule 2. This is something you either have to be able to visualize. Not many people are able to visualize this, or you can make the model. I let you have your model set, and you can do this. Now, I don't know how they came up with this rule, but this is how they do it. So what you do is you visually put the lowest priority group, which remember is group 4, in the back, and determine the circular motion, or the direction, let's call it motion, of the remaining 3 groups. Okay? If it goes clockwise, it is the R enantiomer. If it's counterclockwise, it is an S. Yes, I made a mistake up here. This should not be L, this should be S. Sorry about that. That should be an S enantiomer. If it's clockwise, it should be R. If it's counterclockwise, it should be S. Okay? So let's do that using our molecule. All right, so let's rewrite it on the next page. Now, some people can visualize this. Some people might need to make models. So what you do is imagine that you are grabbing hold of the hydrogen, which is lowest priority, and you put it in the back. Okay, so just imagine in the back. So what that does is it turns your molecule so that the bromine kind of ends up here. That's where your bromine ends up. Your chlorine is on the left side, and your OH is on the, the chlorine is on the right side, your OH is on the left side. Okay? So that's kind of what the molecule looks like when you grab a hold of H. I would make this molecule. Make this molecule with your model. Stop the video, make the molecule, grab the hydrogen, put it in the back so that the 1, 2, and 3 groups, the bromine, the chlorine, the OH, are facing right at you. Okay? So here's my bromine, here's my chlorine, here's my OH. Okay? You look at the direction that this is going in. Okay, so 1, 2, 3, we're going clockwise. That's why this is the R enantiomer. All right, the other molecule, the S molecule, again, sorry about that. Not the L. The L is for the plane polarized light. For this one, the hydrogen goes in the back again. So you have your carbon. Chlorine now is up top. Your bromine is on the right. Your OH is on the left. Bromine was 1, chlorine was 2, OH was 3. Notice 1 to 2, 2 to 3, and 3 back to 1. You're going counterclockwise. So this is the S enantiomer. All right, that is how you do it. So why don't I put a few problems for practice, and you determine what the chirality is of the molecules that I have shown. Let's do NH2, and then let's do one of these. This is different. Let's do one in a ring. So let's do Cl. Let's do CH3. Let's put an oxygen right there. Put on pause and determine what these are. Alright, so the left one should be an R and the right one should be an S. Alright, so let's go over it. So here's my carbon. My bromine is 1, chlorine is 2, nitrogen is 3, hydrogen is 4. Put the hydrogen in the back. So that puts the bromine up top, puts the chlorine on the right, keeps it on the right, the nitrogen on the left. So bromine again is 1, chlorine is 2, nitrogen is 3. Notice the direction we're going in, clockwise, so that's the R. How I remember it is if I'm going to the right, it's R. Alright, always start from 1 to 2. Always go from 12 o'clock to whatever, 4 o'clock, whatever direction you're going. If you're going to the right, clockwise, it's the R. As far as the next one's a little harder because you have a ring, so you kind of have to try to visualize it. Alright, chlorine is 1. Your oxygen over here is 2. Then you have a CH2 and a CH3. Well, the CH3 loses, so the CH2 is going to be priority 3, and this is priority 4. Right? So if you want to try to turn it, this is actually easier. If your lowest priority is already in the back, however it's going on the page is how it actually is. So you don't really have to visualize anything. This is kind of a trick. The previous example, your lowest priority was not in the back already. Alright, so you kind of had to put it in the back. Here, it's already in the back for you. It's going in the back. So just look at where 1, 2, and 3 is, and notice we're going counterclockwise. So that is the S enantiomer.